stop it now.
All right. I really don't care which ones we do. Oh, well, I guess you're the only one that's true. But I have graded some other ones in the other class. All right.
Did you collect mine?
Huh?
I turned it in at the beginning of class, it's not there.
Might be in my pile here. Yeah, right here. Okay, so as you were doing these, I don't care where we start. If you don't give me one, I'm gonna just pick one somewhere. As you were doing these, what was confusing to you? Given?
7.
7. I'm on the 310 homework and doing problem number 7. All right, so let's look at it. Given these two, find the x-coordinates of the points intersect. Okay. That means I'm going to set them equal to each other, right?
Yes.
So 2 cosine sine equals cosine. And we are in our usual domain. All right? So, what do you think we ought to do?
Subtract cosine.
Subtract cosine. Under no circumstances should you divide by cosine. So if you divided, erase it, you're wrong, it's never going to work, it's never allowed. You cannot divide by an unknown. You cannot divide by an unknown unless you are 100% sure it can't be 0. Sine and cosine can both be 0, so we're not dividing by them. Okay, so 2 cosine sine minus cosine equals 0. All right, what do I do with that?
Take out cosine.
Take out a cosine. Take out a cosine. So I'll be left with, if I take out the cosine, 2 sine minus 1. What do I always do after I factor? Set them equal to 0. So cosine equals 0, or sine equals 1/2. Where does the cosine, remember cosine is x, cosine equals 0 at pi over 2 and 3 pi over 2. I think we just did this one. Where does the sine equal 1/2? Pi over 6 and pi over.
So it's just all 4 of those answers?
Those are the answers.
That's what intersection means?
Intersection means something's equal to each other.
Oh.
Where do they equal each other? Now, I want to talk about, anybody have a question about this? All right, I want to talk about number 6 because number 6 is very similar. Would you agree? Are we going to divide by tangent? No. Because why? It could be 0. So we're going to subtract it over. And factor it out. Okay, so far would you agree these problems are very similar to each other, right?
Yes.
Okay, so set equal to 0, so tan equals 0, or sine squared equals 1, which means sine is plus or minus 1. All right, where does the tangent, that's y over x, where does y over x equal 0? 0 and pi. where does the sign equal 1 or negative 1? Everybody's still with me? Now we're going to talk about why we need to do this problem. We need to talk about it. If I solve an equation, whatever answers I get, I should be able to plug back into the original equation and it all works out, right? I mean, that's what we do when we check our answers. Tell me what happens when I take either one of those and put them in there, into that original equation. What is the tangent of pi over 2? Undefined. So these are extraneous, and the only answer is 0 and pi. Now, you should be saying to yourself, whoa, Asworth, how come you didn't check these over here? Well, are the sine and the cosine ever undefined? No. So I don't need to check my sine cosine problems. I need to check the other 4. If it's a tangent, cotangent, secant, or cosecant, you got to make sure that whatever answer you got does not make it undefined in the problem. Got it? Okay. Anything else we need to talk about, look at on this, Danica?
Number 8.
8? Now, 8 is an inequality. So that means my answer will not look like this. My answer will have intervals. So here we go. So what's the first thing? Same domain. So what's the first thing I do? Subtract the 1. And then hopefully figure out a way to factor this. Agreed? Okay, so here we go. Two signs. Does that work, I think? So my key numbers are going to be where the sign is -1/2 and where the sign is 1. So if I'm doing this on the unit circle, or if I'm doing it with a sine curve, doesn't matter. Whatever works for you, that's how you're going to do it. Where is it that the sign is -1/2? Well, that on the unit circle, that would be down here, right? Here and here. In my picture, it would be here and here. Where are those angles? What are those angles? The sign is -1/2. 7 pi over 6 and 11 pi over 6. Okay. Where is it that the sign is 1? The only place it's 1 is right here, right? Half pi over 2? Everybody agree? All right. Now, I factored my problem. I got 2 factors, and I have to be positive, greater than 0. So doesn't that mean that purple and blue both have to be greater than, or they both have to be less than? Does that make sense to everybody? Positive, 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 negative, negative. Okay, so let's do positive, positive first. If you're on your unit circle, That means you have to be above or on, because this is an or equal to. So I have to be above or on both lines. Are there any points that are above or on both of these lines? Just pi over 2. Over here, same thing. I gotta be above purple, above blue, or on. That is the only point right there. So the answer is pi over 2 so far. Now, the other case, less than, would be everything that's under blue and under purple. Well, can you see that would be this right here? Over here, that would be this right here. It doesn't matter, you know, which one you're looking at. So those dots are colored in. So that part of the answer would be 7 pi over 6 to 11 pi over 6. And that's a bracket because the problem was or equals to. Danica, makes sense? Perfect. All right, who else? We got time for one more. Yep.
Number 5.
5. 5 is another inequality. So we need tangent to be less than 1. Tangent minus 1 has to be less than 0. So I'm going to go ahead and factor that. Would everybody agree it's the difference of squares? So I need the tangent to be 1, and I need the tangent to be -1. So I look at my tangent curve, and I gotta go all the way to 2 pi, because that's what the problem says. I use my purple and blue again. This is where the tangent would be 1. So that would be this point and this point. Well, where is the tangent 1? At pi over 4 and 5 pi over 4. And then I want the tangent to be -1. Here and here, and that happens at 3 pi over 4 and 7 pi over 4. Oh, I kind of missed my lines. You get the idea. Okay. Now, this problem says that when you multiply your factors, you have to be negative. So what does that mean? I have to be above 1 and below the other. Okay, so think about this purple and blue. Can I be above purple and below blue? Is that going to be possible? No. So I'm not considering the greater than 1, less than -1 case. That can't happen. Can I be less than purple and greater than blue? Where would that happen? So that would happen here and here and here. Would you agree with that, Ella? Okay. I have to be below. Remember, Ella and everybody else, if you are multiplying and you're negative, that means you have 1 positive, 1 greater than, and 1 less than. So greater than purple, less than blue doesn't work. But less than purple, greater than blue does work. All that. So what's my answer? 0 to pi over 4, or 3 pi over 4 to 5 pi over 4, or 7 pi over 4 to 2 pi. Yep.
Would you get the same answer if you had added the 1 over that's square root of both sides?
Well, you gotta be careful with that. You would get the same, like pi over 4, you get the same angles. But when you square root both sides, you can't say tangent is greater than plus or minus. That's not how it works. You can't do that in inequality, okay? So if you're doing it just to get your values, that's okay. But you cannot say, if I say x squared is greater than 9, that does not mean that x is greater than plus or minus 3. That's not true. Okay, so hopefully we fixed a couple things, so those won't be as disastrous for me to grade. Quinn, did we get some?